Hi all, and welcome to another installment of your MLOs for Math 2201. Help you understand what's going on in this course. We're talking about parabolas again in our second section here. So this is quadratic functions 56th installment, and we're looking at changing the values of the parameter a in the quadratic function's standard form of its equation, ax squared plus bx plus c. We're going to talk about the graph of y equals ax squared for varying values of a. We're going to talk about its effects on the values of a parabola if we choose different values of a. You will remember, first of all, that we had y equals ax squared plus bx plus c. And we've already talked about how the simplest parabola will be just y equals ax squared, or just x squared, sorry. And then we said these a, b, and c values that we could choose to change that would be transformations. So we're going to look specifically at what changing the value of a does to the graph. So instead of just 1, like the simplest one, let's see what different values of a are going to do to our graph here. So we're going to look at some positive numbers that we could use for a, and then we're going to look at some negative numbers that we could use for a. So we'll start with the positives first. So you can see in the left graph we have over here, we've got a bunch of positive numbers chosen for a. So the very first one I want you to look at is sort of the black parabola. That's this one right here. That's along the outside, and that has the equation y equals x squared. That's that simplest parabola that we've seen before. The very basic, sometimes, and even in our older curricula, we used to call that the base function. Okay? So that's our base function. And everything else we do is sort of a transformation of that. So let's look next at the blue one. The blue one is what happens if I take this 1 that we had as a coefficient and we make it a 2 instead. You'll notice that the blue parabola is taller, and we sometimes say narrower, than the graph of y equals x squared. Okay, so when I change the 1 to a 2, it gets taller and narrower. Then we're going to look at the red one, which is the next one inside, and that's when we change that leading coefficient, or the value of a, to be 4. So if I have y equals 4x squared, it gets even taller and narrower. Now let's make a real dramatic jump. For the green one, we're going to go all the way up to 10, and it gets really tall, a really tall, slender parabola. Okay? So basically, if we take the value of a, so if we have y equals ax squared, we take the value of a and we just start making it bigger. So this, remember, if we start y equals x squared was when a is equal to 1. And then if we just start making a bigger, the parabola gets taller and narrower. Okay, so let's start from our base graph again, over here on the right, y equals x squared. And now what we're going to do is we're going to shrink the value of a. We're going to make it smaller, but we got to stay positive for now, until the next slide anyway. All right, so we're going to choose some smaller and smaller values of a. So we go 1/2, 1/4, 1/10, in a similar fashion to what we did previously, but now we're going with small fractions instead of big numbers. And you see what happens is the parabola kind of gets squashed down gradually. So we go from the black one where a was 1 to the blue one where a is 1/2. It gets sort of shorter and wider. Okay, so the parabolas get progressively shorter and wider as we sort of squash them down with smaller values of a. Okay, so that's what's happening there, excuse me. So if we take negative values of a, and I want you to notice if I flip back and forth really quickly from this slide to the previous one, you will see something very similar about the one we just looked at and that one. They're sort of identical, except that they've been flipped over or upside down. All of these graphs that we have over here, they're all the same graphs we had on the last page, except they've been sort of reflected over the x-axis. And that's exactly what we call those. We call those a reflection of the ones that we just looked at. Okay? So these are reflected over the x-axis as if the x-axis was a mirror, and now you're looking at yourself in the lake here, and you can see that you're upside down. So all the same coefficients, we had a 1, a 2, a 10, we had a 4 for the red one, but now if we throw a negative sign in front of it, all it does is it makes all the y coordinates negative, and it just flips everything upside down. And it's the same thing over here when we look at the ones where we went with smaller values of a. An important thing to distinguish is if we want to talk about that stretch that we had on the graph, like how tall it made it, or how short and wide, or how tall and narrow I should say, then what happens is we look at sort of the absolute value. So I don't know if you're very familiar with absolute value, but if I just take absolute value with a couple of bars, I mean, I just want to know what we're talking about here for what's the number without regard for the negative or positive? Okay, so the absolute value, or just the number without the negative sign, tells us how tall, narrow, short, wide, what kind of things we do to the shape of the graph. The negative part, if there's positive or negative or whatever, the sign of it tells us whether we reflect it upside down or not. Okay, so let's look at the effects on the properties of a graph. And here's a whole bunch of positive ones, and here's a whole bunch of negative ones. Does the vertex change for different values of A? Remember, we had vertex, axis of symmetry, and direction of opening were important features of the graph. So there's no change in the vertex when we vary up the value of A, or we use different values of A. So the vertex stays the same, because you'll notice every parabola that we have, whether we had positive, negative, big or small number, doesn't matter, the vertex is always in the same place. The axis of symmetry also, no matter what value of A we choose, always stays right along the y-axis there for those particular ones. So the value of A doesn't change the axis of symmetry either. The direction of opening does change. If it's positive, our graph opens up, and if it's negative, our graph opens down or downward. Okay, that's the key distinction. So there's really two effects of the value of A. It affects the shape and it affects the direction of opening. Okay, so sometimes we call this letter A the vertical stretch of the graph. So if A is a number bigger than 1, the graph gets taller and narrower, and if it's less than 1, it gets shorter and wider. If it's a positive number, the graph opens upward, and if it's a negative number, the graph opens downward. However, it has no effect on the axis of symmetry or on the vertex. Okay, so that's the first of the three parameters A, B, and C that we have to look at. Hope you found that helpful.